if you coming to the microparticles means like atoms, electrons, protons. Okay, classical mechanics does not explain the those behavior. Okay, those behavior. So that's why quantum mechanics came into the picture. Quantum mechanics came into the picture. Yesterday we also discussed about the statistical mechanics also. Okay, so in that statistical mechanics, so what is the use of statistical mechanics means that statistical mechanics is bridge between the classical mechanics and quantum mechanics. Okay, so that means classical mechanics deals with macro particles, no? So quantum mechanics deals with micro particles. Suppose if you want to relation between the macro and micro properties. Macro and micro properties means so for explaining that means relation. So bringing the relation between micro properties and macro properties means so we need one more mechanics, that is the statistical mechanics here. Okay, so that is no needed right now. So presently we will discussing about the quantum mechanics. Okay, why quantum mechanics is needed means for explaining the properties of microparticles. So micro objects means like that electron, proton, atoms and the nucleus. Okay, these all. Okay, yeah. uh, yes, how that these quantum mechanics came into picture means so for explaining the black body radiation, Max Planck proposed some rules. So based on his theory, Max Planck theory, so he proposed some theory to explain the black body radiation. So based on this theory we'll develop the quantum mechanics. Okay, so this is about the origin of quantum mechanics. Okay, so what is the use of quantum mechanics means yeah, the phenomena of interference. Classical mechanics does not explain the interference phenomena, diffraction, polarization. Okay, and so these all phenomena, photoelectric effect and Compton effect, were explained so based on the particle nature. So that means so these phenomena, interference, diffraction, polarization, so these are explained using wave nature of the light, so but photoelectric effect and Compton effect so does not explain using the wave nature of light. Okay, so that means if wave behave like, that means radiation behave like a wave, only wave means so that photoelectric effect and Compton effect so we cannot prove. Okay, so for explaining the these photoelectric effect and Compton effect, so we need one more, that is the one more theory, that is the quantum mechanics here. That means so according to quantum mechanics, light is considered as a so dual nature. That means light have both natures, wave nature as well as particle nature. Okay, so according to the quantum mechanics, but according to classical mechanics, wave have only wave nature. So that means radiation have only wave nature. Okay, now coming to the third point. So electromagnetic radiation has so dual character, already we discussed. In certain situation it exhibits properties of wave, while in other it acts as a particle. So based on the dual nature of radiation, de Broglie hypothesized the concept of matter waves, which is base of quantum mechanics. Okay, so that means based on this dual nature, so that here radiation we are discussing, initially radiation have dual nature, as well as de Broglie proposed that matter is nothing but electrons, protons, these all. Okay, these all also have dual nature. So that means actually we treat that so electron is like a particle and proton is like a particle. But de Broglie proposed that so these matter also have dual nature. So that means this matter also have, it behave like a particle as well as wave. Okay, so based on quantum mechanics, he explained how those will be, electron will behave like a wave as well as particle. Okay, yeah. So next one is, to understand the concept of dual nature, we have to know the characteristics of wave and particles. Okay, so what is the wave, how waves will behave, how particles will behave, so we should have some idea. Okay, now coming to the, yeah, so black body radiation. black body radiation. So this is the first topic and important topic in quantum mechanics. So this is very important. This is the origin of how quantum mechanics is developed. Okay, yeah. So black body radiation. What is the initially? So we have to know what is the black body. What is the black body? So black body means a body that absorbs the entire radiation instant on it. Okay, once again, a body that absorbs the entire radiation instant on it is called perfect black body. Perfect black body. So when it absorbs all radiation means that body at lower temperatures. That body at lower temperature. So whatever the radiation is instant on it, it absorbs total radiation. It absorbs total radiation, whatever instant on it. Okay, so that is called our black body. Now coming to the another point. So whenever heated to this black body, whenever heated to this black body, it emits radiation at all frequencies, whichever instant previously on it. Okay, so it emits the radiation. It emits the radiation at all frequencies, which is known as black body radiation. So whenever you heat the black body, it emits the radiation. That radiation we will call it as black body radiation. That means black body is nothing but here. So whenever it will be in lower temperature, whatever the radiation is fall on it, it absorbs total radiation. It absorbs total radiation. Whenever we will heat that black body, it will emit all radiation, whatever instant on it previously. Okay, yeah, it emits the all radiation whenever we will heat that body. Okay, so at lower temperature it absorbs, at higher temperature it emits the radiation. That means black body is a good absorber as well as good radiator. Black body will act as a good radiator as well as good absorber. Okay, it it neither reflects nor transmits any of the instant radiation and therefore appears like a black. Okay, so why it is appear, why we will call it as black body means, so it absorbs total radiation whatever fall on it, that's why it appears like a black. So that's why we will call it as this is a black body. Okay, now coming to the so next para. So no actual body is perfect black body. No actual body is perfect black body. That means perfect means, so whatever fall on the radiation on it, it should be total absorb. So then only we will call it as that is the perfect black body. But in actual case, there are some only 99%, 95%. So like that absorbs. Okay. So if you will take lamp black. So lamp black is the so best example for black body. Best example for black body. It absorbs nearly 99% of instant radiation. It absorbs 99% of instant radiation. Okay, so lamp black we will observe in our house also. So like take a candle, so take a one white sheet, so keep that white sheet on a candle. Okay, so after some time we will that appears some black shade on the white paper, black shade on the white paper. So that is a carbon. Okay, so that is act as a so a good black body. Okay, yeah. Lamp black is a type of carbon black obtained from the obtained from the soot of burned fat, oil, tar or resin. So how we will get the that carbon black means, so for burning the fat, oil, tar or resins. Okay, lamp black is very stable and unaffected by a light. An ideal black body can be made by taking halo sphere also. Okay, halo sphere also. See here. Uh, so this is the, see here. So this is the halo sphere. This is the halo sphere here. Okay, so here light is instanting on here. So that means this is the total one sphere. We are taking sphere, inside it will be halo. Sphere means like a football shape. Football shape. Okay, inside it will be halo. Okay, and we will will make one hole on the surface of the surface of the sphere. So what is the use of that hole means? So it enters the, that means it allows the light inside whatever fall on it, so it allows inside. Okay, so whatever the light allows instant on it means that will be total internally reflected, and it is absorbed by the this halo space. Okay, so why it absorbed means this halo space is coated with carbon black, coated with carbon black here. Okay, so that's why whenever light is instant on here, so what happened, so it will be so opposite to the hole, so there is some pyramid shape will be there, so that reflects the whatever light fall on it. That reflected light is instant on the this S, that reflected light is instant on the so surfaces of the inner surfaces of the these inner surfaces of the this sphere. So that inner surfaces is coated with the black body, coated with the carbon or here lamp black, coated with the carbon or lamp black. So that reflected light is absorbed by that lamp black. If any light is remaining means, so again it absorbed by the another surface. So that's like that it absorbed inside the black body. It absorbs inside the black body. See here, inner surface is coated with the lamp black. Any radiation enter into the cavity through the hole instant on the inner surface of the cavity, and it surface multiple reflections inside the cavity and finally absorbs. The probability of radiation of any wavelength escaping out of the hole is negligible. So that means whatever the ray is instant on it, that totally absorbed by the this black body, this black body, and so it is absorbing totally. That's why it appears like a black. Yeah. So now, so this is at what is that? This black body at normal temperatures. Whenever we will heat the black body, what happen? So it will, yeah. So when the cavity is heated to the temperature, so the emitted radiation uh, fills the cavity and then leaves from the hole. Hole act as a perfect emitter. Okay, whenever we will heat the black body. Who is that making noise? Yeah, so now, yeah, whenever we will heat the black body, what happen? It will emit the radiation, because at lower temperature it absorbs the radiation. Whenever we will heat that, so it emits the radiation. So like if you will take iron, so iron is not perfect black body, but if you keep it in that means sun rays, it absorbs some radiation. So okay, so whenever heat it, it emits the radiation. Suppose if you heat it at a particular 100 degrees centigrade, it emits a particular color. Okay, like that. So black body also same like that only. If whenever it will be lower temperature, whatever light instant on it, it absorbs. Whenever we will heat it, it emits whatever the radiation it absorbs, it emits whenever we will heat it. Okay. Okay, so yeah, that means here emitted radiation. What is the behavior of emitted radiation? Whenever heat the black body, it emits the radiation. So what is the behavior of that emitted radiation? We'll observe here. So in this graph, here we will draw the graph between so wavelength versus radiation intensity. Okay, so how much the radiation will be emitted? Intensity of radiation. Okay, so here intensity of radiation is taken on y-axis and wavelength is taken on x-axis. Okay, whenever heat the black body, it emits the radiation. So that how that radiation will behave means, so by using this graph, that is the wavelength versus radiation intensity graph. Okay, if you observe the at 200 Kelvin, see this graph. So lower curve is the, so at 200 Kelvin, sorry, 2000 Kelvin, the behavior will be like this. The behavior will be like this. So at lower wavelengths, see here. Okay, so that intensity of radiation is very less. Intensity of radiation is very less. If you increasing the wavelength, that means increasing the wavelength, that means at a lower wavelength the intensity will be less. If you increasing the wavelength, so radiation will be, see here, radiation will be increases up to particular value, and so at a particular wavelength lambda value, that radiation will become maximum at a particular wavelength lambda, that is called as lambda m. Okay, that is the lambda maximum. If you increase the further wavelength, that means if you go to the further wavelengths, what happened? So the intensity of radiation is decreases. Okay, so that decreased, and finally it will reaches to the very small value. So like how it will be means, in our class, if you will take in our class, so many number of students will be there. So if you in our class 60 members of students will be there. Okay, so that their marks ratio. So here number of students we will take on y-axis, so their marks will be taken on x-axis. Okay, suppose here, so 5 marks getting students, so very small. 5 marks getting students are very low number of students will be there. So how many number of students will get, so that means suppose here 50 marks. If you will take 50 marks, so 50 marks means, so maximum people getting 50 marks. So if you will take out of 100, how many people are getting 100 marks means very less people. Like radiation also like that only. So at lower wavelengths, intensity of radiation is small. Intensity is nothing but number of lines emitting to the black body. That is the intensity of radiation. Okay, so if you will take unit area, how many number of lines passing through that unit area, that is called as intensity of radiation. Okay, so that intensity of radiation is at lower wavelengths it is small, at higher wavelengths it is small, at average wavelengths it will be maximum. That is depends on the wavelength, how radiation will be, intensity of radiation will be changes. Okay, now coming to the, yeah, so if you increase the temperature, so we observe here, increase the temperature, what happened? So radiation also, emitted radiation also increases. So this curve inside the area, so this is the one curve na? Inside the area gives the, so total energy of the how much, suppose here we are taking 200 Kelvin, 2000 Kelvin. So how much radiation is, how much total energy is emitted at 2000 Kelvin. So area under the curve gives the how much energy, so emitted, at 2000 Kelvin. Now if you will take 3000 Kelvin, means, so this area also increases. That means, so if increasing the temperature, so energy density also increases, and intensity of radiation also increases. So, and see here, if you will take lower wavelength region, so intensity also, so that means if you will take only this curve means, so here intensity of radiation is less. So if increasing the wavelength, so intensity of radiation is increases up to particular lambda m value. So after that, if you increase the further wavelength, what happened? So intensity of radiation is decreases. Like that, if you increase the temperature, so every curve loop area is increases. That means energy density will be increases, as well as we'll observe one more thing. So this is the lambda maximum. Lambda maximum means at a particular wavelength, intensity of radiation is maximum. Okay, that is the lambda maximum. That lambda maximum is shifted lower frequencies. If you increasing the temperature, that lambda maximum is shifted lower frequencies. Okay, with increasing the temperature, lambda maximum is shifted lower frequencies. shifted lower frequencies. That means lambda is inversely proportional to the temperature. Lambda max is inversely proportional to the temperature. Lambda maximum is inversely proportional to the temperature. Okay, so this is about the radiation. This is about the black body radiation curve. If you draw the graph between wavelength versus intensity of radiation, that curve will be like this. It is depends on the temperature. With increasing the temperature, energy will be increases. Energy will be increases. Okay. Now coming to the one more thing here. Yeah. So one more thing we will discuss. What is that means? So why radiation is emitted here? 1 minute. Yeah. So that black body is, if you heat the black body, radiation, that means radiation is emitting. What is the reason for emitting the radiation? Anyone can explain? Suppose if you heat the iron, so it will that what happen after certain temperature, it will emit the radiation. It will emit the radiation. If you change the temperature, means what happen? So that color also changes. That color also changes. Okay. So I will explain you why like that. Okay. Now, so what is the reason for emitting the radiation? So black body is at room temperature, at normal temperature, it does not emit any radiation. If you increase the temperature, it emits the radiation. What is the reason? Anyone can explain? Yeah. So if you will take any body, if you give some heat or any energy, if you give any energy, what happen means, so that inside the body so many electrons or atoms will be there. Okay, so if you heat the body, what happen? Those atoms will vibrate. So because of vibrations, what happen? So it will emit the radiation. It will emit the radiation. Okay, so because of that vibrations, what happen? So some radiation will be emitted. So what is the frequency definition? Number of vibrations per second. If number of vibrations will be less, means so that emitted radiation will be less. If number of frequencies more, means that emitted radiation will be more. So that means if increase the at lower temperature, so number of vibrations will be less. So that's why less frequency will be emitted. Okay. If you increase the temperature, what happens? So number of vibrations will be increases. And more particles will vibrate. That's why intensity of radiation will be increases. So more particles are vibrating. If you increase the temperature, suppose if you will take 2000 Kelvin, only certain particles are vibrate. If you take more, that means 3000 Kelvin, more particles are vibrate. So more particles are vibrating means more radiation will be emitted. That's why intensity of radiation is nothing but so what is that? Number of radiation lines emitted per unit area. That is intensity of radiation. If you increase the temperature, means intensity of radiation is increases. What is the reason? Means so if you will take any body, if you increase the temperature, means inside the atoms will be vibrated. So if you increase more temperatures, means more atoms will be vibrate. So like that. So it depends on the temperature. See here. So depends on the temperature. If you increase the temperature, what happen? More atoms will be vibrate. So because of those vibrations, so radiation will be emitted. So at higher temperatures, more atoms will be vibrate. That's why intensity of radiation also increases. Okay, so that is regarding about the black body radiation. Okay, for explaining the black body radiation. So many theories came into the picture. So first is the Wien's theory. Next one is the Rayleigh-Jeans theory. Okay. So according to, based on the classical mechanics, assumptions, they proposed those theories. So but those theories does not explain the black body radiation. Okay. So that's why Planck's came into the picture here. So Planck's based on the quantum theory, he proposed some rules, and based on rules, he explained the black body radiation. Okay, we will discuss about the what are the failures theories and what is the Planck's theory. What is the Planck's theory? So tomorrow. Okay, so I will take the attendance. So